Our world pulsates with an invisible force, a silent conductor of our most vital technologies. This electrifying marvel is the dance of electricity and magnetism. From smartphones to electric vehicles, their influence is undeniable. These phenomena drive modern civilization. Everyday miracles we take for granted, the glow of our homes, the communication networks, the life-saving instruments in hospitals, all are testaments to electricity and magnetism. Understanding these forces begins with atoms, where electrons unlock electricity's mysteries. Join us in exploring this electrifying connection, unraveling the principles that shape our world. To understand the magic of electricity, we must first journey into the minuscule world of atoms. Imagine a bustling metropolis on a microscopic scale. At the heart of this city lies the nucleus, a dense core orbited by even tinier citizens, the electrons. These electrons are not just passive bystanders. They are the key players in the story of electricity. You see, electrons possess a property called electric charge, often described as negative. This charge is the driving force behind the electric phenomena we witness every day. Think of it like this. Imagine each electron holding a tiny sign that reads negative. When these negatively charged electrons start to move, they create a flow of charge. This flow, my friends, is the essence of electricity, a river of charged particles coursing through wires and circuits. But what causes these electrons to break free from their atomic orbits and begin their electrifying journey? The answer lies in understanding the concept of electric potential difference, commonly known as voltage. Picture a water slide at a bustling water park. The higher the platform, the greater the potential energy, and the faster the water rushes down the slide. Similarly, in the world of electricity, voltage acts like this height difference, creating a force that compels electrons to move. Voltage, measured in volts, is the driving force that pushes electrons through a conductor, much like the water pressure pushing water through a hose. The greater the voltage, the stronger the push, and the greater the potential for electron flow. This flow of electrons, our electric current, is measured in amperes, often shortened to amps. It represents the rate at which these charged particles move through a circuit. You can imagine it as the number of electrons passing a point in a wire per second. But just like a water slide with varying widths and twists, the path of electrons is not always smooth. They encounter resistance, a property that hinders their flow. Resistance, measured in ohms, is like the friction in a pipe, trying to slow down the flow of water. The electricity that powers our homes and industries doesn't magically appear at our fingertips. It embarks on a fascinating journey from its source to the socket. A journey fueled by the remarkable interplay of energy transformation and electromagnetism. Imagine the colossal turbines within a hydroelectric dam, their blades churning tirelessly as water surges through them. This mechanical energy, harnessed from the raw power of nature, is then used to rotate massive generators. These generators, often resembling gigantic, intricately wired drums, are where the magic happens. They employ the principles of electromagnetism to convert mechanical energy into electrical energy. It's a mesmerizing dance of spinning magnets and copper coils, a testament to human ingenuity in harnessing the forces of nature. But water is just one of the many energy sources we've learned to tap into. Wind turbines gracefully slicing through the air, solar panels basking in the sun's radiant glow, and even the heat emanating from the Earth's core and geothermal plants all contribute to this electrifying symphony. Section 5. The Enigmatic Force. Unveiling the Mysteries of Magnetism. From the simple compass guiding explorers across vast oceans to the powerful magnets driving electric motors, magnetism has captivated humanity for centuries. It's a force that seems almost magical, invisible, yet capable of exerting a tangible influence on the world around us. But what exactly is magnetism? It all boils down to the behavior of electrons within atoms. You see, electrons are not just charged particles. They also possess an intrinsic angular momentum, a property we call spin. This spin gives rise to tiny magnetic fields around each electron, turning them into minuscule magnets. In most materials, these atomic magnets are randomly oriented, their magnetic fields canceling each other out. However, in certain materials like iron, nickel, and cobalt, these atomic magnets can align their poles, creating a net magnetic field that extends beyond the material itself. This alignment is what gives rise to the magnets we know and interact with. They possess two poles, a north pole and a south pole, where the magnetic force is strongest. Like poles repel each other, while opposite poles attract, just like the positive and negative charges we encountered in electricity. Section 6. A powerful partnership, electromagnetism, and its guiding hand. For centuries, electricity and magnetism were considered separate entities, each with its own set of rules and mysteries. But in the 19th century, a groundbreaking discovery revolutionized our understanding of these fundamental forces, revealing their intimate connection and forever changing the course of science and technology. Enter James Clerk Maxwell, a Scottish physicist whose genius illuminated the interconnected nature of these seemingly distinct phenomena. Maxwell's equations, a set of elegant mathematical expressions, unified electricity and magnetism, showing that they were not separate entities, but two sides of the same coin, electromagnetism. Maxwell's equations revealed that a changing electric field creates a magnetic field, and conversely, a changing magnetic field creates an electric field. This revelation was nothing short of revolutionary, laying the foundation for our modern understanding of light, radio waves, and the entire electromagnetic spectrum. Section 7. Faraday's Law in Action, From Generators to Electric Dreams. One of the most profound consequences of electromagnetism is embodied in Faraday's Law of Induction, a principle that underpins the operation of countless technologies we rely on today. It's a testament to the power of harnessing the invisible forces of nature to drive innovation and progress. Imagine a simple experiment. Take a coil of wire and move a magnet back and forth through its center. As the magnet's field lines cut through the coil, something remarkable happens. An electric current is induced in the wire. This, my friends, is Faraday's Law in action. It tells us that a changing magnetic field can induce an electromotive force, EMF, which in turn drives an electric current. This principle is the foundation of electric generators, the behemoths responsible for generating the vast majority of our electricity. But Faraday's law's influence extends far beyond power plants. It's the driving force behind transformers, those ubiquitous devices that step up or step down voltage levels to ensure efficient power transmission and distribution. It's also the fundamental principle behind electric motors, converting electrical energy into mechanical energy to power everything from electric vehicles to industrial machinery. Section 8. Electromagnetism in our pockets. Powering the modern world. Look around you, and you'll find countless examples of electromagnetism silently at work, powering the devices and technologies that define our modern world. From the smartphones we hold in our hands to the electric vehicles silently gliding down the streets, electromagnetism is the invisible force shaping our digital age. Consider the smartphone a marvel of miniaturization and technological prowess. At its heart lies a complex network of circuits and components, all intricately connected and powered by the principles of electromagnetism. Every time you make a call, send a text, or browse the web, you're witnessing electromagnetism in action. Electric vehicles, heralded as the future of transportation, are another testament to the transformative power of electromagnetism. Powerful electric motors, driven by the interaction of magnetic fields, propel these vehicles with remarkable efficiency and zero tailpipe emissions, paving the way for a cleaner, more sustainable transportation system. But the influence of electromagnetism extends far beyond consumer electronics and transportation. Medical imaging technologies like magnetic resonance imaging, MRI, rely on powerful magnets and radio waves to peer inside the human body, providing detailed images of organs and tissues without invasive procedures. Section 9. Beyond the Basics. A glimpse into the future of electromagnetism. As we delve deeper into the 21st century, the field of electromagnetism continues to evolve at an electrifying pace, pushing the boundaries of our understanding and unlocking new possibilities that promise to reshape our technological landscape. Scientists and engineers are exploring the potential of wireless power transfer, a technology that could one day free us from the tyranny of cords and cables. Imagine a world where your smartphone charges wirelessly as you move about your day, or electric vehicles receive power dynamically while driving down the road, all thanks to the magic of electromagnetism. The development of new materials with exotic electromagnetic properties is another exciting frontier. Metamaterials, for instance, are artificially engineered materials with unique electromagnetic responses not found in nature. These materials hold the potential to revolutionize optics, telecommunications, and even energy harvesting. From the quest to develop super-efficient energy storage systems to the exploration of quantum electrodynamics, the study of electromagnetism at its most fundamental level, the future holds endless possibilities. As we continue to unravel the mysteries of this fundamental force, we can only imagine the transformative technologies and scientific breakthroughs that await us.